Okay, so the last section is 2.7, which is measures of the spread of the data. So we already talked about the middle, right? But what happens about the spread of the data? How does it spread to be skewed left, or how does it spread to be skewed right, right? And so we're going to go ahead and take a look at it. And what I always start with is always a set of 3 sections quiz scores. And I think this is a really good way to grasp how spread is just as important as your measures of center of data. Okay, so here I have 3 sections, and you'll notice that the average is 5 and the median is also 5. Okay, for all sections. So section A is average is 5 and median is 5. Same with B and section C. But their data looks different, right? Look at the scores. They look different in each section. They're not all 5s, all 3 sections, or all 10s, 8s, or all 3 sections. So how do they all have the same average and median, right? Well, that's just it. Your data can be different, but your centers can be the same. And because why? It's calculation of your center. Right? But then if I look at section A closely, notice that it's uniform, right? Every score is the same. It's 5. So let me go over here and let's talk about the spread. Right? So this is the center over here, and then over here will be the spread. Okay. So is there any spread in section A? Did anyone get a different score than 5? No, there is no distance from this average 5. This is the average of 5. Is there any distance from 5 in any of these scores? If you said no, you're absolutely correct. What about B? Section B has 5 zeros and 5 tens. If the average is 5, what is the distance from the average to these scores? Well, from 0 to 5, that's 5 units. From 5 to 10, that's also 5 units. So what is the average distance from the mean, right? Well, 5 units, because 5 is in the middle, right? Well, now let's look at section C. We notice we have 3 4s, 4 5s, and 3 6s. If the average is 5, which are these scores, then what is the distance between 5 and all these scores and 5 and all these scores? Well, from 4 to 5 is 1 unit, and from 5 to 6 is also 1 unit. So the average distance from the mean is 1 unit. So now let's take a look. We have 3 sections of quiz scores. All have an average of 5 and a median of 5. That's the center. But when I start looking at average distance from that center, I notice that it's different for each section. I notice the first section didn't have any distance from the mean. That the section B had 5 points from the mean, and section C had 1 point from the mean. So the spread is different on 3 different sets of data that have all the same average and median. This is why spread is so important to talk about, because we want to look at the data in its full transparency. So there are 3 types the way we measure center, right? We are going to do the average distance from the mean, which will be standard deviation, and the other one will be range. There is a third spread value that we're going to talk about when we talk about the standard deviation. The range is just giving how much our data spreads. Our data spreads has a range of, in our case, 10 in section B, right? The range of points is 10. The range of points here in my data were 2, right? Because the highest score was 6, the lowest score was 4. In section A, the spread here was, you're like, well, there wasn't any because everyone got the same score. And I'm like, exactly. So the range was 0, right? There's no range. So let's take a look at the range. So here are some peanut butter jar examples. And, peanut butter jar prices. And the range of these will be just taking the most expensive jar, which is $3.99, and subtracting the most inexpensive jar, which is $3.29. So if I subtract these, I get 70 cents. And that's the numerical answer, right? But how would I tell this to my friends, right? How do I start a conversation about it? And it's really simple. We would just say the peanut butter prices or jar prices range by 70 cents. Okay, pretty simple, right? Okay, let's move on to the standard deviation. There are some things you need to know about standard deviation. First of all, standard deviation is a distance. It's a distance, an average distance from your mean. And so we take that to in literal sense because distance is never negative, right? I don't ever say, I ran -5 miles today. What does that mean? The world owes me 5 miles of running, right? So no, we really don't. Distance isn't negative. So standard deviation isn't negative. So the standard deviation will be always positive, right? And 0 if all the data values are equal, like in that section A of quiz scores, right? And has the same units as the original data and highly influenced by outliers. So the standard deviation is not resistant. So it's very careful to understand that. And then we interpret it as taking the average and we give or take the standard deviation, right? If it's the average distance from the mean, that means the mean is this value, give or take one of these, right? One of these in each side. It's equal distance from the mean. And we'll be interpreting that. So we denote also, I want to highlight, is by sigma or S. Remember that sigma will be the population standard deviation, and little s is not, it's nice because we did S for sample standard deviation. So how do you remember? Well, S is for sample and then the sigma is for population. So here are the formulas that you could use when calculating the standard deviation by hand. It is quite lengthy, especially when you have a lot of pieces of data, and we rarely do it by hand. And we will always do it on technology because that's how the real world works. We just do it on technology. Okay, and so here we have the denominators to be a little different. We assume data is always a sample. We rarely have the population, right? So we always assume sample and we always assume this denominator. However, if it's given to us that it's a population, we'll use the number of observations in our data set. But if it's a sample, we cannot use the number of data in our data set. In fact, we use n-1. And some students always wonder, like, why that is. I'll do it, but I have no idea why that is, right? Well, I'm going to just tell you a little idea that I always tell my students is if I had 5 pencils sitting on the desk and I had 5 students that needed pencils, if that first student comes and asks for a pencil, right, do they have a choice? Do they have the freedom to choose which pencil they want? Yeah, they do. What if that second student comes? Well, there's 4 pencils left. They have the freedom to choose. That third student comes, they have a freedom to choose out of 3 pencils, right? The fourth student comes, there's two pencils left. They have the freedom to choose which one they want. Who doesn't have the freedom to choose which pencil they want? That last one. And that's what we do. We take away that one subject that doesn't have the freedom to choose, and that's marked right there. And so that's just the way the sample standard deviation works. And that's the idea. You're going to learn a lot more about degrees of freedom when we get into future chapters. But this kind of gives you the idea of where that -1 comes from and why it's different from the population. Okay. So here is the formula, right? You would take each data value and subtract the mean. You would need the average first, right? Then square it, then add them all up, and then divide by n minus 1. We are always going to divide by n minus 1 because we always assume sampling. But if we're given that it's a population, then we can go ahead and divide by n, and then we can take the square root. So step 5, don't forget about step 5. This is the square root. Okay, and then we just note here that in step 4, when we divide by n minus 1, that's actually called the variance. And the moment we square root it, it becomes standard deviation. So the variance is like in default, we get this value from trying to obtain the average distance from the mean, which is standard deviation. And we're going to do that in our next example. So I'll show you by example. So here are the prices of jars for the peanut butter. And so the mean of the peanut butter prices, so the first thing you would want to do is find x bar. Okay, and then if we did x bar in the calculator, we would see that we would get the average to be $3.68. And so I'll go ahead and put leave to student, LTS. And you could find the average by adding these 5 numbers up and dividing by 5. And so here is 3. I'll put 368 in each of these boxes. Okay, so the second part would be now to subtract each data value from their mean. So I would do 329 minus 368, 359 minus 368, and so on. And so go ahead and take a moment and do that. Okay, so I hope you went ahead and just put that in the calculator. Make sure you do order, right? Because when the data value is less than your mean, your values are negative. And when your data values are greater than your mean, this difference will be positive. And now we're going to take each of these values in red and square it. Okay, so I took each of those values here and squared it. Make sure you put parentheses because anything squared should be positive. Everything in this last column should be positive. And if it's not, it's just the way you're entering it on the calculator. Okay, just recall that these should be in parentheses like it shows on the table in your notes. And so now we can see that we squared all these differences and now we have these values. Now what I want to do is sum all of these up. And what does that mean is that I'm just going to add this column. And put the value here. So go ahead in your calculator, add up all these values and put your answer here. Go ahead and take a moment to do that. Okay, and so now that we've done all the steps that we need, we're actually now on step 4. So step 1 was to go ahead and, let's go up here, to find the difference and then square it and then sum them. So these are the first few steps of this problem. Here's step 1, here's step 2, and then here's step 3. And so now we can go ahead and move on to step 4. And step 4 is we're going to go ahead and divide by n minus 1. Okay, and since there are 5 peanut butter jars, n is equal to 5, and then we get 0.2733 divided by 5 minus 1. So if I put that in the calculator, we can go over here. Let me clear this one out. I'll put 0.2733 divided by, and then parenthesis 5 minus 1. I always put numerators and denominators in parentheses. It's a good habit. And I get 0.068325. Okay, and so then step 5 would be to take this value and find the standard deviation. In this case, it's a sample, so S. So S will just be the square root of 0.068325. And don't round right now. Don't round this number off. As we said in the beginning of this chapter, round in the end. Always round in the end. Okay? So if I took the square root of this number, so second x squared, that square root is there. I'm going to go ahead and put second answer, which is a and s with the negative. And what that a and s does is grab the answer directly previous from it and then hit enter. So I get this large sequence of numbers, right? And so this, where do we round to? Well, just round one digit past your data, right? Use the rule of thumb. So we have 0.26, and then rounding one digit past our data, which was cents, would be the thousands place. And if we round in the thousands place, we have to look at that test digit, which is 3. It's below 5, so we just keep it 1. Great, so there's your standard deviation. This is if you did it all by hand. Now, let's talk about step 4. Step 4 is an important value to us, and this is called the variance. Okay, so the variance is going to be the standard deviation before you square root it. So there's a couple of ways to look at the variance. So let's put a note here. So the variance is equal to the standard deviation squared. Okay, or you can look at it as the standard deviation is equal to the square root of the variance. So when you're asked about the variance, it's really because you're given this value and process of finding the standard deviation. You're going to use the variance a little bit more in your research methods class when you get into your future stat class. Okay.